This is lesson 7.5 on proportions and triangles. So first of all, I would like you to, on the picture that's shown there, label A, B, C, D, E, and F, because that makes it easier to understand what's happening in the diagram. So the side splitter theorem says that in a triangle, if you have a line that's parallel to one side of the triangle, then it cuts the other two sides of the triangle proportionally. Now, according to the labels that are over here, that means XR, I'm looking at this proportion, XR is to RQ as YS is to QS. So if you use the letters that I have there, it says F is to E as D is to C. Now there are many different proportions that are all equivalent to that, so you might notice that you could also say E is to F as C is to D. So that's kind of using the top to the bottom and then the top to the bottom on the two sides. And we still have similar triangles, so it's still true that triangle QRS is similar to triangle QXY, and that's because if the lines are parallel, then you have corresponding angles that are congruent, so the triangles are similar by angle, angle. So because the triangles are similar by angle, angle, you can still use the idea of similar triangles. So you can still say on this diagram, for example, that in the small triangle, side to bottom, so E to A, is equal to, in the large triangle, this side to that side, the corresponding sides. So that would be E plus F over B. Now, I'm telling you this because I want to caution you that it's really common, the most common mistake in this whole entire chapter is that people try to say E to A and F to B. E to A and F to B does not work. And the reason it doesn't work is because F is not a side of the triangle. So if you're using parts over here, if you're using a side there and in a segment here, you have to be using a side here and a segment here. If you're using the bottom segments here, those are sides of triangles, and F is not a side of a triangle. Okay, so E over A and then F over B, or any such equivalent proportion, does not work because F is not a side of a triangle. Okay, so if you're using the parallel segments, this is if you're using the parallel segments. If you're using the parallel segments, then must use similar triangles. Now, if it helps to think about this in terms of triangles that are pulled apart, so you can kind of look at this and say, okay, here's a triangle there that's QRS. And then here's a triangle QXY. If you're going to be using RS, which was our A here, and XY, which was our B, and then QR is E, this whole side, QX here, this whole side is not F. That whole side is E plus F. Okay, and so it makes sense that if you say E is to A, as you are down here, E is to A, as E plus F is to B. You cannot just be using F because F is not a side of the triangle. And again, you can use any equivalent proportion. So if you want to say E is to E plus F, and kind of bounce back and forth between the triangles, that is to that, as A is to B. The the sides of the triangles are to compare to each other, and then the bottom of the triangles are compared to each other in the same fashion. But again, just caution, do not be using that segment right there. Okay, so some examples. Find the value of x. So side splitter theorem says, okay, these are parallel. This only works if they're parallel. So that is to that as the piece here is to the piece here. So 18 is to 6 as x plus 22 is to x plus 2. Resist the urge to try to simplify that. It doesn't work that way, since if you cancel something on the top or bottom, it has to cancel on the other part also. 18 over 6 is 3. X plus 22 over x plus 2 is the other side. And then we're going to cross multiply, remember to distribute. 3x plus 6 is equal to x plus 22. So 2x equals 16 and x equals 8. Okay, second example. Determine whether the segments are parallel. Well, if they're going to be parallel, that means that the sides have to be proportional. So we have AD is 15, and DB is 12, and AE is 10, and EC is 8. So we're just going to check, is it true that 15 to 10 is equal to 12 to 8? Now, you could also check 15 to 12 and 10 to 8, for example. There's lots of different proportions you can check. I'm just doing the ones that kind of look, like the equation looks like how the picture looks. So on the left side, take out a 5, that's 3 to 2. On the right side, take out a 4, that's also 3 to 2. So that works. Remember also, you can verify by cross multiplying, and that tells you that 120 equals 120, which means that they're proportional, and therefore BC is parallel to DE because the segments are proportional. Okay, next example. Now, notice that you have parallel segments again. So we know that these sides should be proportional, which they are. Both of those ratios are 1 to 1. But if you think about, again, we're using the parallel segments here, and every time you use the parallel segments, you want to be thinking about similar triangles. Again, that's what I was saying up here. If you're using the parallel segments, use similar triangles. Use similar triangles. Okay, if you're using which these would be your parallel segments, use similar triangles. So that means that the ratio, because these are congruent, this compared to this, let me do it this way, this compared to that is a 1 to 2 ratio. So using the similar triangles, that means x to 35. If the scale factor is 1 to 2, that also has to be, x and 35 have to be in the same ratio. So that would give you x equals 17.5. Now, you might also notice that that's a mid-segment. Remember that a mid-segment joins the midpoints of two sides of a triangle. This segment is a mid-segment. So, and this is working because the fact that those are midpoints. So this is a mid-segment. That won't always be a mid-segment just because it's parallel. On this one, it's joining midpoints, so it's a mid-segment. It's half the length of the side of the triangle to which it's parallel. So if we double x, if we double the mid-segment, we'll get 35, and therefore x is 17.5. Or it's half the length of the mid-segment. So, I'm sorry, the side. So the mid-segment is half of 35. Okay, and then the next problem, notice that they have 11 and 33. And again, we have parallel segments here, so we can make this one 22 because it's the rest of the 33. And then our proportion would be x is to x plus 12 as 11 is to 22. That's 1/2, right? X is to x plus 12 is equal to 1/2. So 2x is x plus 12, and x would be 12. Now again, you could use similar triangles. You could say x is to the whole side here, x plus 12, as 11 is to the whole side here, which is 33. Okay? Oops, sorry, mistake, wrong. Let me fix that. X is to 2x plus 12. I marked it, but I wrote the wrong thing. X is to 2x plus 12, as 11 is to 33. And notice these proportions are different because the bottom of the left one is 2x plus 12 instead of x plus 12. And if you cross multiply this, you'll get the same answer. Okay, second idea. Corollary to the side splitter theorem. For this one, it's really the same idea, just the diagram looks a little bit different because you don't have a triangle. Notice that if you extended this up, you'll have a triangle there. And sometimes you'll see problems where there are triangles instead of just parallel segments. But this one will say that, again, I labeled the picture here a little bit differently. M is to N as P is to S. So part there is to part there, as part there is to part there. And again, that's the same idea as the previous one. You can also go back and forth and say M is to P as N is to S. So M and P are compared, and then N and S are compared. So any equivalent proportion would work. Okay, that means, again, you want to pay attention to the fact you have parallel segments there. So that makes 5x compared to 3x equal to x plus 12 over 12. Or you could say 5x is to x plus 12 as 3x is to 12. Now, I want you to notice that this proportion on the left side is going to be easier because you can divide out the x right here. And then when you cross multiply, you're going to have 60 equals 3x plus 36. So 24 equals 3x, and x equals 8. On the other one, if you cross multiply, notice that right here, when you go x plus 12 times 3x, you're going to get 3x squared plus 36x. It's a lot easier to compare them as this one to this one. Now, could you do this? Absolutely. You're going to have to get a quadratic. It will factor. One of the answers will be negative, which means it doesn't work in the original problem because you plug in a negative, it'll make those segments negative. And you'll get there, the same answer. It's just obviously a lot easier to do it this way instead. Okay, second example. Notice that you do again have parallel segments. And this time, those are congruent. That means you can just say 2x plus 4 is equal to 3x minus 1. And so x equals 5. And then since that's a 1-to-1 ratio, that makes this also, these are also in a 1-to-1 ratio. In other words, they're congruent. So these two are not the same as the first ones, but they're still going to be in a 1-to-1 ratio. So that means that 3y is equal to 2y plus 12, and 2, and y equals 2.